Assalamu alaikum everyone. I'm Inam. I'm thrilled to welcome you all to this video lecture on mechanics of solid. In this video lecture, we will be discussing about Mohr circle. By solving a numerical, we can easily understand the concept of Mohr circle method. In Mohr circle, we will be using a graph which is consists of x-axis and y-axis. On x-axis, we will be using the normal stress, and on y-axis, we will be taking the shear stress values. So with the help of these coordinates which consist of normal stress and shear stress, we can easily draw a circle, and with the help of circle we can find the normal stress and shear stress respectively. So this will be the introductory part in which we will be understand the concept of Mohr circle. The objective of the Mohr circle is to find the normal stress and shear stress. Normal stresses are those stresses which acts perpendicular to the surface, and shear stresses are those stresses which acts parallel to the surface. So in this video lecture we will be determining the normal stress and shear stress at any plane without any calculation. So with the help of this question we can grab the concept, determine the principal stresses. This is the first part of the question, and question is here. You can see the stress block. And in another video lecture we will be discussing this part, that normal and shear stress at an angle of 50 degrees anti-clockwise. In next video lecture we will be solving this video lecture. So this step for all video lecture, all lectures related to the Mohr circle is same, is constant. So if you grab this concept, you can apply this also in this question. So remember this. So I am require your concentration. So the first step for drawing a Mohr circle method is to understand the coordinates, to pick up the coordinates correctly. If you do mistake here, the whole your question will be wrong. So remember this. So here you understand this is a stress block and normal forces are applied here, and this is a shear stress. So normal stress is 50 megapascal, which is tensile in nature, and here is the normal stress which is perpendicular to this surface area, and it is 60 megapascal. And the shear stress here is in this side is anti-clockwise 40 megapascal, and here in this side is 40 megapascal clockwise. So before moving towards the solution, you first understand the sign convention. Whether you are solving in case of mechanics of solid, or you are solving in subject soil mechanics, the sign convention will be changed. So in mechanics of solid, remember this, in mechanics of solid, the sign convention for tensile stresses will be positive. The tensile forces are taken as positive. Here you can see that it is tensile in nature, so this value will be positive. And the compressive means here it is compressive in nature, and this value will be taken as negative. So the compressive value will be taken as negative. While in case of in soil mechanics, the tensile are taken as negative and the compressive are taken as positive. So remember this. I am solving this numerical in case of mechanics of solid subject. So the clockwise stresses will be taken as positive. Here you can see that this is a clockwise stress and it can be taken as positive, and anti-clockwise or counterclockwise will be taken as negative. This value will be taken as negative because it is counterclockwise. So first we understand the sign convention for mechanics of solid. So with the help of this, we will be drawing the first step is to drawing the coordinates. With the help of coordinates we will draw a circle. If you do any mistake here, so the whole concept, the whole solution of your question will be wrong. So the first coordinate will be this, it is 50 megapascal. So I am writing the coordinate in this term. The first value will be the normal stress and second value will be the shear stress. So on x-axis will be taken the value of normal stress, on y-axis we should took the value of the shear stress. So for this side, I am writing the first coordinate, it is 50 megapascal, which is tensile in nature, means plus 50, and for shear stress it is of 40 megapascal, which is clockwise in nature, means both 50 and 40 are positive. So I am taking both the values as positive, 50 and 40. The first value will be normal stress and the second value will be the shear stress. Remember this. Now for second coordinates, you should know the nature of the force, which is stress, which is compressive, means this is will be the -60, and this is counterclockwise, means anti-clockwise, this will be -40. You can, with the help of sign convention, you put the positive or negative signs. So the second coordinate will be -60 and -40. With the help of this, we will be using a graph with the suitable scale and mentioning these 2 points. So this will be the step 2. Step 2 is that 40 and 50 on y-axis on this graph is here. This is on x-axis 50 and on y-axis 40. So I am selecting this point. And the second value is -60 and -40. So -60 and -40 is here. So it means on x-axis we will be moving to the left, which is -60, and on y-axis, which is downward, -40. So the meeting point will be here. So these will be the 2 points. With the help of these 2 points, we will be drawing a circle. So now I am drawing the third step for this question is drawing the circle. So for circle, first we using the graph, and on x-axis will be the normal stress, on y-axis there will be a shear stress. So I am putting the marking the marks of the data points of the coordinate, which is 40 and 50 here, and -60 and -40 is here. The next step is putting the ruler and drawing the line to meet these 2 points, straight line. So I am drawing the line here. So you can see that I draw a line which meets this and this coordinates. The next step is to find the center and putting the compass and open it until this end and draw a circle. So next step I am drawing the circle. So this step for all question of the Mohr circle is same. So now the next step is to draw a pole point. So with the help of pole points, next calculation will be carried out. So I am using the same. So I draw this line as in last slide and draw a circle. Now I am drawing the pole point. This theta point is -40 and -60, and this I am only be moving to the up or down. So remember this, in this point, in this coordinate, I am only be going up or down. So I am going up because down, in down there will be no circle. So I am putting straight ruler and drawing a line. In this coordinate here, this coordinate is here. In this coordinate I am only moving to the horizontal only. So in this I will keep a ruler and draw a line. So I draw a line where these 2 lines join. This point will be called as a pole point. So this is the very important point in this circle. With the help of this, next calculation will be carried out. So you can see that what I did in last slide, I draw a line, straight line and a circle, and these 2 lines which is represent the stress block. Remember this, these 2 lines represent this stress block side. You can see that it's a horizontal, here it's a horizontal, and it is a vertical, and you can see that vertical where both points meets. This point is called pole point. With the help of pole points, we can determine the principal stresses. Principal stresses are those stresses where shear stress value are equal to 0. Here in this circle you can see that only 2 points where the shear stress value equal to 0. Number 1 is this point and number 2 is this point. Means the y-axis value equal to 0. So I am from 4 point I am drawing a straight line to meet this point and this point respectively to know the principal stresses. Means this is a minor principal stress and another is this point, which is major principal stress. With the help of ruler, I join this pole point to this point and this pole point to this point. So correcting the value with the suitable scale, so I can get the value of the minor principal stress and major principal stress. These are very important. Remember this. This step for all videos remains same, means from pole point further calculation will be carried out. So you know that how to draw a pole point, how to draw the principal stresses. Now in next slide, what will be the value of the major principal stress and minor principal stress. Minor principal stress value will be minus 73 megapascal. From graph I am taking this value. So major principal stress value will be 60 megapascal. So with the help of Mohr circle, without any calculation, we found the value of the principal stresses. So in next video lecture, we will be solving the value of the normal stress and shear stress at any plane. So this video lecture is the basic intro of the Mohr circle, that how we will draw a pole point, how we find the principal stresses. So thanks to everyone.